Hey everybody, this is Larry. This is April 24th, 2024. And here I am trying to do an algo problem that I haven't done yet, so let's get to it. RNG, add bold tags in string. Finally, a problem that's not hard, so I could maybe finish a little bit early. Okay, so what are we doing? So you're given a string S and an array of words. You find tags or words to kind of bold. Okay. It could be very tricky though. I mean, I think this is okay. So you're trying to do a minimum. It's the same as another problem. Okay, fine. Did we do that other problem? Ah, we did. All right. Well, I mean, I think this is a medium, but it's not really that good of a medium. Maybe minimum. Is that true? Now, let me see. What is the most naive thing I can do, right? So we have there the list of words. Mm, I'm trying to think, to be honest, just like the laziest thing I can do. So there are 100 words. So if we try to do 100 words for each of those characters, it's not going to be enough. So can we be a little bit smarter? There are going to be n square substrings, and if you kind of do like a rolling hash, you could do it that way. But is that an overkill? I don't know. Why don't I know KMP well enough? You can also do this Z function thing n times, but which actually should be fast enough, but you know, I am going to do that. I don't know that much about Z function though, so I'm not going to lie. I am Googling it. I'm doing this because it is something that I have not done before. So, or like I've done it like once or twice. I've done it in contests because I'm forced to. But I am going to ask ChatGPT to give me Python's Z function in Python, please. Let's see if it gives it. Okay, looks okay. Maybe we'll see if that works. Right. Okay, so now we have this Z function, right? You have a string, and then okay, that's return to do that. Let me just see how that works. This print function. So then now, basically, what does Z function do? And I don't think you need it for this problem, just to be clear. I think you can Google this if you like. I would also just say, I know how to do this with, what's it called, Baltimore? Oh, no, Robin Corp, sorry. Robin Corp or rolling hash, right? You can hash every word and then just do a rolling thing on the S on every length. So you can definitely do that. But I just want to try something new and funky, something that maybe I'm a little bit just don't know that much about, and thinking about it in a new way, right? And I know that, and I thought about it very briefly, and I don't know how this algorithm works, to be honest. So you should Google it. I don't know how it works. I need to learn it one day, but I know how to use it, and the way to use it is, I believe, it gives you the set function gives you the length, the longest length that matches the prefix, right? So then here, maybe you have something like this, then it means that starting from, like for example, this 3 is the 5th character, which means that this A has a 3, you know, is the same as 3 things in the beginning, right? Okay. Yeah, AAB is AAB, so that's why this is 3, and so forth. And the reason why this can be used, and I just kind of thought about it very briefly, is because then now we can just create a new string for each of these and then calculate them out, right? Because for example, we can say for word in words, we can do word plus S as a new string and then do a C function on this, right? And then now for every index, and maybe I think this works anyway, but maybe I can just add like a pound sign so that it doesn't so it doesn't like overlap with itself in some funky way, in case that there was a big thing. Right, so I think this actually makes it good, and this actually is a pattern that comes up a lot in suffix tries, or what's it called? I guess that suffix try, suffix array, and all these things. But so I'm just trying to play around with it and see if I can learn, or just have some practice, to be honest, right? And then now, given this, we can say for let's just say z is equal to this, and then now we can say for I for the index and x in enumerate z, what is it, right? So if x is equal to the length of word, then that means that we matched all word, and that means that this is a good prefix, right? This is a good prefix. I'm trying to think whether I need to be super careful, but I think it's fine, maybe, right? And then now we can do there are a couple of ways you can do this, and I'm going to do this the most efficient way, I suppose, which is with now you can think about it as, okay, now if x is equal to word, we want to mark off the index from I to I minus the length of the word, right? Or did I say minus? I and I plus length of the word, right? So you have this interval. And of course, there are a couple of ways you could do it. You could create like interval or segment data structures and stuff like this. The way that I'm going to do it is for prefix, right? Because a prefix or difference array, I think is actually what it's called. So I'm just going to difference array. I still think about it in terms of prefix sum, because you do a prefix sum on it, but people call it differences array, which I guess makes sense. And the idea here is that we only need n items, where n is the length of s, right? I guess technically n plus 1, so that you can terminate beyond, or at n rather, right? So then now here we can do diff of I is equal to, we increment by 1, and then diff of I plus x we subtracted by 1, right? And then that's pretty much it, really, right? I mean, I'm going to still return some stuff, but then now we can print it out just for visualization. I'm confident. I mean, maybe add some silly stuff like this, I suppose. Oh, because the pound sign is, it includes itself at the very end, so I think that's why. But okay, so if I'm just kind of lazy. If I is greater than, well, maybe I just take the first up to the end. Maybe that should be good. Okay, so then you could see that the difference array, what it's saying is not good enough, right? All right, let's print this out real quick. Word z function. So word is ABC. Huh. Why doesn't... Did I mess this up? Oh, I messed this up. I did it in the wrong order. I confused word and s. Okay, so this is way... Yeah. Because we want the word in the back so that it matches on the prefix, right? Wait, no. This is right. Because we want... But okay, but this has to start after the length of word is what I mean. Okay. Maybe plus 1 for the because this is the plus 1. Okay. Okay, so this looks way better, right? Okay, yeah. So I got the indexing wrong. But the idea I was confident about. Like I said, implementation, that's why I'm practicing, right? But here, this is the beginning, and then you want to get, so S is the input string. We want to find out where it matches word exactly, and for that we can do the z function. And here we don't care about the beginning of the word because we just don't care. So because we actually care about the where in S it occupies, and this is where you get the difference array. And with the difference array, you can see that okay, it matches the first 3 characters here, which is good, and so forth, right? And then now with the difference array, we can just step it through. Yeah, okay, right. Which is, and with a current, just like a prefix something. Though you could probably just roll it in, but it's fine. Yeah, and then now if current is it's equal to, so basically we're trying to find the beginning, right? So okay, so we have let me also set up the answer real quick, right? So basically yeah, if current is equal to, if what we want is if current is equal to 0 and diff sub I is greater than 0, then we create, that means that it went from not being inside the boat to being inside the boat. Then we want to just append the boat thing, and now we add it, and then now we want to add in the character, right? If I is less than n. The reason is because, so then now we can say if current is equal to 0 and diff sub I is greater than 0, then we want to append the ending tag, because this looks exactly the same here, but it is after we added this. So that means that after we, oh, this is less than 0, whoops, because that would never happen. Basically, we're saying that if it is now 0 because we moved it, then we it went from being in the boat to not being in the boat. So that's basically what it's saying. Yeah. Okay. What am I? Oh, maybe I've been off by 1 though. Because this x. Maybe this has to be on the next I. Yeah, maybe that has to be before. No, that's after we changed it. So why would that work? No, that doesn't make sense. I mean, this, maybe this one. Because basically the way that I did it is that this is exclusive, meaning that I plus x is actually not in it. But I have to think about the indexing here, which is why it's a little bit awkward for sure. But the reason why I did this is so that it does this thing, right? What? Because when we looked at the array, when we looked at the difference array, we can see that it was on the right index, I think. Yeah, because here we want to say the -1 is before we add the string. But well, this cannot be right. But if this is greater than 0 and current plus is equal to 0, maybe, I don't know. Does that work? I guess that works, because basically we want because it's exclusive. That means that this should happen before the well, this part. This part doesn't matter that when the time. So I guess actually I could have kept it the same way, but put it before adding this thing. And the reason is because we chose exclusive bounds for here. But now that I think about it, I don't know that I'm that confident. But and we could play this out in some cases, but I don't know what's a good case, to be honest. So I don't know. So I might just YOLO submit. Why is that not valid? Oh, I have to close it. Whoops. I mean, it looks okay, but yeah, I'm just gonna submit it. To be honest, I'm not 100% confident. There's just some edge cases maybe with the off by 1, because the inclusive exclusive bounds I'm always really bad at. So I know that that's one of my weaknesses that I need to work on. But yeah, as you can see, this works pretty okay. It is accepted. It's a little bit slow apparently. Maybe there is a, well, no. The way that I do it is a little bit, the Z function is not that cheap. Oh, it is. It's linear. So okay, let's go over the complexity really quickly, right? I don't know how to do it much faster, to be honest. How did I do it last time? Let's take a look. But the z function is O of n for the size of the string, but for each word, and there's 100 of them, we concatenate a new string, which is up to 2,000 in length. So this is going to be the number of word times n, right? So w times n, if you will. And then, and then this is also O of n, because it just, it just gets the result here. So it's O of n, and this is O of n. So in total, it's going to be O of w times n, which is 100 times n, which is probably fine. But apparently it's a little bit slow. How did I did the other one? I don't even remember. So apparently it's the same problem. This is just like brute force. I think the constraints are much smaller, so you can do the brute force. I don't think that's a reasonable thing. I am going to take a look. Mark bold characters. That is terrible. Or is this just the timeout one? I don't know. This seems like what the. It uses fine to get the next. Okay, fine. I don't know. This seems very brute force. I don't know. It may be faster because a lot of string functions in Python are fast compared to, and the reason is because a lot of string functions are coded in C. So I don't know. It's fine. That's all I have for this one. I hope you enjoyed it. This is new for me. I probably would have used Robin Carp, but this is a nice way to practice this Z function and then kind of coming up these things. And I'm not gonna lie, I had a vague idea. I knew that I could do it with this, but I didn't have the, like when I was writing, only when I was writing it did I realize like, oh, how do I solve this other part? I forgot to think about it. And I was like, oh, difference away is fine, right? You could also probably have done some n squared stuff and probably is fine, but it probably would have been very slow. Yeah, I don't know. It's pretty interesting, pretty cool. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.